Hello friends, myself Dnyandip and today we are going to discuss about the 8th standard topic of physics, that is inside the atom. Now, before going inside the atom, we have to study what is the atom exactly means. Now, let's move toward the matter first of all. Now, what is the matter? Now, what is the definition of the matter? In the case of the atoms and the molecules, that's the matter is made up of the molecules. Means matter is made up of the molecules. Now, what is the atom is? Atom is also the smaller particles from the molecule, that's a form from the atoms. Now, first of all, firstly, that's the matter. Matter is made up of the molecules, and molecules is made up of the atoms. So here we can say that the atoms is the smallest particle of the matter. So matter is made up from the molecules, and the molecules are also from the atoms. Now, what is the atoms? Atom is the smallest particle of the matter. So we can say that this atom can neither be indivisible or the destructible. Means atom is the indivisible and the indestructible. Means it is the smallest unit of the matter. Means if we start to dividing the matter into the smaller parts, then at last we get the smallest part, which can be indestructible and undividable. Means which cannot be divided further or cannot be destruct further. Means it is the smallest part of the matter and we call as a atom. So what is the exact definition of the atom? The atom is the smallest particle of an element which retains its chemical identity in all the physical and the chemical changes. Means while we know that the elements goes in various physical and chemical changes. For example, while forming the compounds or any elements combines to form new elements. For this phenomenon, the elements has to undergo the many physical and the chemical changes, so that you have to further divide the elements into the smaller particles. For example, if we take the molecule of the hydrogen, then it can be further divided into the atoms of the hydrogen, that is the H and H. These two atoms form the H2 molecules of the hydrogen. Means this is the H means the smallest particle of an element, means this is the smallest particle of the hydrogen which retains its chemical and physical property while undergoes any chemical and the physical changes. Means its properties doesn't change at any condition because it is the smallest part of the matter. So we studied the definition of the atom. Atom is nothing but the smallest particle or the smallest element particle of an element which retains its chemical identity in all physical and the chemical changes. सोप्या भाषेत सांगायचं झालं तर ॲटम म्हणजे काय? ॲटम म्हणजे स्मॉलेस्ट पार्टिकल आहे की जो फर्दर ना डिवाइड केला जाऊ शकतो ना डिस्ट्रक्ट केला जाऊ शकतो. सो ॲटम, when atoms comes together, it forms the molecules. म्हणजे atom हा सर्वात लहान युनिट आहे. It is the smallest unit of the element. When the atoms comes to close together, it forms the molecule, and when the molecule form, it forms the matter. So we understand this chain, that is the atom forms the molecule and the molecule forms the matter. So you can say that the atom is the smallest particle. Now we see the history of the atoms. Now this is before the 6th century BC. The Indian philosopher, that is a Kanan, states that the matter can be divided up to certain limits. Means there is a limitation in the destruction and the division of the matter. Means matter आपण एका particular limit पर्यंतच त्याला divide करू शकतो. When the destruction or the division of the matter stops, means when we get the smallest particle. For example, this is the matter. When we divide it, we get the smallest particle, that is the molecules. When we further divide these molecules, we get the smallest particle, which cannot be further divided. And this particle which cannot be further divided means there is a limitation for the division and the destruction of the matter, which last, or we divide this matter up to these particles, and this particle which is indivisible and the undestructible, this is called as a Parmanu, and this Parmanu is nothing but our atom. So before 6th century BC, Kant states that there is a limitation for the destruction of the matter, and at the last we get the particle which cannot be further divided. So that particle named as the Parmanu by the Maharishi Kant. Now also the Greek philosopher Democritus also state that there is also a limitation for the division of the matter. When we divide the matter, at last we get the particle which cannot be dividable and destructible further. Means this is undestructible particle, that's called as a atom. Means the Greek philosopher Democritus named that particle as an atom, and the Indian philosopher, that's the Maharishi Kant, named that particle as a Parmanu. So up to now we have learned that what is the atom. Before going inside the atom, we have learned the definition of the atom. Now what is the atom in our language? That is, atom is the smallest particle. Means smallest particle की ज्याला आपण फर्दर डिवाइड करू शकत नाही आणि त्याला फर्दर आपण डिस्ट्रक्ट पण करू शकत नाही. Means atom is the smallest particle, and the smallest particle gets together to form the which particle? That's the molecules. And when the molecules comes, or when the molecules forms, they need to form the matter. So inside the matter there are the molecules, and inside the molecules there are the smallest particles known as the atom. In a scientific language, the definition of the atom is what? It is the smallest particle of an element which retains its chemical identity in all the physical and the chemical changes. Means while undergoing the various physical and chemical changes during various reactions, the chemical identity of this atom retains. Means the chemical identity of this atom while undergoing any physical and chemical changes. Fitness means it does not change at any cost while going any physical or the chemical changes. So this is the definition of the atoms, and we have seen the history of the atom, that Kanad, who is the Indian philosopher before 6th century BC, and the Democritus, that is the 5th century BC, named that smallest particle as the atom, and the Maharshi Kanad named that particle as the Parmanu. So, in the previous lecture, we studied the definition of the atom. We have seen that the atom is made of, atom forms from the molecule, means the molecule is made of from the atoms, and the molecules formed in the matter, means the atom forms the molecules, molecules form the matter. Now, we have also seen the history of the atom, that is the Kanad and the Democritus. Now we are going to study the various theories of the atom. Now in 1803, scientist John Dalton put forth the theory of the atom, that the theory that is known as John Dalton atomic theory. According to the John Dalton, the atom is the smallest particle of element which is indivisible and the indestructible. And we have also seen that before, that the atom is the smallest particle which is indivisible and the indestructible. So the John Dalton says nothing new about the atom. He just says that the same elements having the same types of the atom, and the different elements have the different types of the atom. But the atoms in the element means the single element or the elements having the same type of atoms inside it, and the thing that is, it is indivisible and indestructible. We have also studied before that, according to the Maharshi Kanad and according to the Democritus, that the particle is the small, that the atom is the smallest particle of the element. So the Dalton, according to the John Dalton's atomic theory, the atom is the indivisible and the indestructible, and it is the smallest part of the element. And also the same elements having the same atoms, same types of the atoms, and the different elements having the different types of the atom. For example, consider any element. In this element, it is made up of the atoms. So in this element, the types of the atoms are all same, means that these elements having the same type of the atoms. So this is the atomic theory of the John Dalton, which is put forth in the 1803. Now let's move on towards the 1904. That is a scientist name, that is J.J. Thomson. Now the J.J. Thomson put forth the atomic theory by using the model. That is which model? That's a plum pudding model. According to the J.J. Thomson, he put forth the theory of the atomic structure by using the model, that is a plum pudding model. Now this plum pudding model uses the structure of the atom. Before 1803 or before 1904, the J.J. Thomson or the John Dalton, the Kanad and the Democritus all say that the atom is the solid part. This is a solid part of the atom which cannot be indivisible. But the J.J. Thomson is the first scientist which used the atomic structure. Means he says that there are also some charges or the particles inside the atom. So the plum pudding model of the J.J. Thomson is the first model of the atomic structure. Now what the J.J. Thomson says? In 1903, J.J. Thomson says that he takes the plum pudding model. Now it is not any scientific model. What is the plum pudding? Plum pudding is nothing but the sweet dish. How it looks like? Consider this is a dish. field, and plum is nothing but the types of the dry fruit, and these dry fruit are spread over this plum in such type. So J.J. Thomson take the sweet dish as or to explain the structure of the atom. So he said that according to the plum pudding theory that the positive charges are present all over of the atom, like this whole dish. Means the positively charged particles are present all over these atoms, and the negatively charged particles are embedded like the plum dry fruit on this dish. Means these are the whole positive charged particles which are present throughout the atom. Consider this is the atom, then these positively charged particles are present throughout the atom, and the negatively charged particles are embedded on these positive particles, so that these positive particles and these negative particles cancels each other, and the charge on the atom is neutral. He says that the atom is neutral because that the positive charge particles are present inside the atom and the negative charge particles present inside the atom. To understand this, he put forth the plum pudding model. Now, what is the plum pudding model? That is a plum pudding model. In this, it is one type of the sweet dish. In this, the dry fruit which is the plums are spread over the sweet dish. Same also in the atom. If we consider this is a dish and we consider this is an atom, then also all the atoms or the positive charges are spread all over the atoms, and the negative charged particles are only embedded on this positive charged particles. So this negative charged particle, this embedded negative charged particles and all the positive charged particles get cancelled each other, and so overall the charge on the atom is the neutral. So the charge on the atom is neutral, means the atom is the neutral. So this is the J.J. Thomson's plum pudding model and John Dalton 1803, that is the John Dalton atomic theory. म्हणजेच 1803 पर्यंत आपण बघितलं की ॲटम म्हणजे काय, तर एक सॉलिड पार्ट आहे. ॲटम इज नथिंग बट अ सॉलिड पार्ट विच कॅनॉट बी इंडिव्हिजिबल अँड इनडिस्ट्रक्टिबल. But in 1904, when the J.J. Thomson comes, he says that atoms also have some charged particles inside it, and so the J.J. Thomson puts the first atomic structure. म्हणजेच 1903 च्या आधी कनाद, डेमोक्रिटस, डाल्टन यांनी एकच कन्सेप्ट सांगितलं आहे की ॲटम इज द स्मॉलेस्ट पार्टिकल विच कॅनॉट बी इंडिव्हिजिबल अँड द इनडिस्ट्रक्टिबल. परंतु जेव्हा J.J. थॉम्सन यांनी प्लम पुडिंग मॉडेल मांडलं त्याच्यामध्ये ॲटमला सुद्धा डिवाइड करण्यात आलं. मीन्स there are also some charged particles inside the atom. Means before the J.J. Thomson the atom is the smallest particle, but after the J.J. Thomson we discovered the many particles inside the atom. So the J.J. Thomson plum pudding model is the first atomic structure model. Dalton's experiment, that is Dalton's atomic theory and J.J. Thomson's plum pudding model. Now we are going to discuss about the Rutherford experiment. Rutherford in 1911 performed the experiment, that is the gold foil experiment. So what is this gold foil experiment? In this gold foil experiment, Rutherford took the gold foil which is very thin, that is near about 10 to the power minus 4 millimeter. So consider this is a gold foil. Now he bombarded the alpha particles which are emitting by the any radioactive substance. When the radioactive substance plays here, the alpha particles get bombarded on the thin gold foil. Now, in this experiment, he gets concluded that he get the following conclusion that when the alpha particles get bombarded on the thin gold foil, then some alpha particles are transmit or get passed through this gold foil without any deviation. So, some alpha particles get passed through this gold foil without any deviation. This is his first conclusion. That is, he gets some alpha particles pass through this gold foil without any deviation. Then, some of the alpha particles shows the deviation with a smaller angle, and some of the alpha particles show the deviation with a larger angle. So, when he finds the alpha particles, he gets the first conclusion that some alpha particles pass through this foil without any deviation, and some alpha particles get deflected with a small angle. Deflected with a small angle. And some alpha particles get deflected with a larger angle. So, here you can see that this is the deviation of the alpha particle with a smaller angle, and this is the deviation of the alpha particle with a larger angle. Now, in some conditions, the alpha particles get reflected back or travels the same path as of the incidence. Means these alpha particles gets incident along this path and gets reflected back with the same path. Means it gets reflected back as the same path, and this is happens only in a 1 out of 20,000 alpha particles. Means when the 20,000 alpha particles get bombarded on the gold foil, then only the one single alpha particle gets back reflected as of the same path. So he get the conclusion or he get the result of this experiment that some alpha particles are passes through this gold foil without any deviation, and some alpha particles deflected with a small angle, some alpha particles deflected with a large angle. म्हणजेच जेव्हा सर्व अल्फा पार्टिकल्स पास करण्यात आले तेव्हा काही अल्फा पार्टिकल्स लार्जर अँगलने डिफ्लेक्ट झाले, काही अल्फा पार्टिकल्स स्मॉलर अँगलने डिफ्लेक्ट झाले, काही अल्फा पार्टिकल्स गोल्ड फॉइल मधून सरळ निघले. म्हणजे याच्यामध्ये काही ना काही दिस फर्स्ट result or his first conclusion said that there is some empty space between this structure of the atom, and our last means the fourth conclusion is that the sum means only one alpha particles out of the 20,000 alpha particles, that this alpha particles get reflected back or follow the same path as of the bombarding path. Now from these four conclusion or from these four result, he put forth the structure of the atom. In the previous experiment, the J.J. Thomson in in the 1904 state that there is some charged particle in the structure of the atom. Now the Rutherford also put forward this structure of the atom on the basis of these four results of that Goldfield experiment. Now what are its result, or how the structure of the atom looks according to the Rutherford? Then the first assumption or the first conclusion of this experiment is that the positive charge nucleus is present at the center of the atom. This is the first conclusion of this experiment, that the positive charge nucleus is present at the center of the atom, because the only one particle of the 20,000 alpha particles, the only one particle get reflected back with having the same path as that of the bombardment, so that it shows that the center of the atom is fixed and it is the positively charged. So this center is nothing but the nucleus and it is the positively charged. Now the second conclusion of this experiment is that the entire mass of the atom is concentrated at the center of the atom, means the entire mass of this atom is concentrated at the center. Now the third conclusion is that the electrons, means the negative particles, which are the electrons, are revolving around the nucleus. He shows that or proves that with the help of the Goldfield experiment, because some alpha particles get deviated or deflected with a small angle of deflection and some with a larger angle of deflection, means that certain particles are revolving around this fixed part, means these are revolving around this fixed part and this is nothing but the electron. Now the third conclusion is that the center nucleus is the positively charged and these electrons are the negatively charged. So this negative charge electrons cancels the positive charge of the nucleus, so that the overall charge on this atom gets neutralized and this atom is neutral, means the overall charge on this atom is neutral, because the negative particles of the electrons get cancelled with the positive charge. Now to get the charge neutral, what we have, that's negative charge and the positive charge. When the negative charge equals to the positive charge, means the negative charge nullifies the positive charge, then we get the neutral. So what we have, the negative particles in the structure of the atom, that is the electrons are the negative, and what are the positive, that is the nucleus is the positive. So the overall charge on the nucleus is what? That's the overall charge on the nucleus is neutral. So these are the four conclusions. First is what? The center is positively charged, that is we call as a nucleus. Second what? The entire mass of the atom is situated at the center, that is in the nucleus. And what is the third conclusion? That the negatively charged electrons cancels the positive charge on the nucleus, so the overall charge on the atom is neutral. And what is the fourth conclusion? That this structure or the atom having some empty spaces between it, and this shows, or this we found this conclusion because some alpha particles during the experiment are passed or transferred through this Goldfield without any deviation. This shows that there are some empty spaces are present inside the structure of the atom. Okay. Now these are the four conclusions of the Rutherford experiment performed in 1911. Okay. Now in the first, that is Kanad states that atom is a solid part or the solid particle which cannot be indivisible or indestructible. Also, the Dalton says the same thing. J.J. Thomson, Dalton in 1804, J.J. Thomson in 1904. J.J. Thomson in 1904 also said that the atoms having some particle inside it by using the plum pudding model. And now the Rutherford also explained the structure of the atom, that the center is a nucleus with all mass is concentrated at the center and the electrons are revolving around the nucleus. Now, until now we have studied this is the structure of the atom. Now what we get now according to the Rutherford, that is this is the atom and center is means whole mass is concentrated at the center and the center is a positively charged. We know this. And just atom बद्दल आपल्याला एवढी माहिती आतापर्यंत मिळाली. Now next scientist is who? That's a Niels Bohr. And according to the theory of Niels Bohr or according to the experiment of the Niels Bohr, he stated the three things. That is the electrons which are revolving according to the Rutherford, the electrons are revolving around the nucleus and there are the empty spaces are present inside the structure of the atom. And according to Niels Bohr, which performed the experiment 1914, that is these electrons, that's the negatively charged electrons revolving around the specific orbit. Means this electrons revolves around the nucleus in a specific orbit, and this specific orbit has some specific energy. Means these electrons having some specific energy which are moving in a specific orbit around the nucleus. This is the first conclusion or the first postulate of the Niels Bohr. Now what's the second? That this neutron from the second orbit or the neutrons from the outermost orbit can be transferred or can be jumped inside the innermost orbit by gaining the energy. As every orbit or every shell having some specific energy, so that these electrons can transfer or can be jumped inside the outer orbit or can transfer from the outer orbit to the inner orbit, the outer orbit, by gaining some kind of the energy or gaining a specific amount of the energy. Now, how much energy does this electron, for example, this is the second orbit and this is first orbit, then how much energy is required by this second orbit electron to jump inside the first orbit electron? This is the energy difference between these two shells or the orbits. Suppose the energy of the first orbit is 5 and the energy of the second orbit is 3, then there is a difference of the 2. So if the electron of the outer orbit gains the energy of the 2, it measures in the electron volt, that the energy is measured in the electron volt. If this outer orbit electron absorb the energy of the 2 electron volt, then by gaining the or absorbing the energy of the 2 electron volt, it gets jumped or gets excited in the innermost orbit. So these are the three postulates of the Niels Bohr. That is the electrons are revolving or the moving around the specific orbit outside the nucleus, and this all the electrons have the specific amount of the energy, and the electrons can move from outer orbit to the inner orbit by absorbing some amount of the energy. And how much energy means exact how much energy? The difference between the energy of these two shells or the two orbits.